Now we are going to start data types. Let us discuss the data types what we had till Oracle 8i. Then we move on to the data types that are introduced in Oracle 9i version. Till Oracle 8i we had data types of char, varchar or varchar2, nchar, nvarchar2, number, date, raw, long, long raw, row id, urow id, blob, clob, nclob and b file. These are the data types that were available till the version of Oracle 8i. In In 9i, the timestamp data types were added in the version 9i. Here we have timestamp, timestamp with time zone, timestamp with current time zone, timestamp with local time zone, interval year to month and interval day to second. These are the data types that were added in the version Oracle 9i. Let us start with the basic data types, which are char and varchar. Let us start with char data type. Char is a fixed length character data type. It is a fixed length character data type. Size specification is optional. It is not mandatory to specify the size for char data type. The default size is 1 byte. That means when we do not specify any size for char data type, the default size it will take is 1 byte. The maximum size of char data type is 2000 byte or 2000 characters. The size can be specified either in byte or in characters. The characters that are allowed into char data type is capital A to Z, small a to Z, that is uppercase alphabet, lowercase alphabet, the digits 0 to 9 and all special characters. That means in general terms all printable characters are valid to enter into character data type. Now let us take an example. Okay, we discuss varchar data type, then we go into the practical session. Varchar and varchar2, out of these two, varchar or varchar2, they are both same. There is no difference between varchar and varchar2. The original data type is varchar2 and varchar is the modified form of varchar2. So initially they introduced varchar2 data type. Later on they modified, they added one more data type like varchar with the same functionality as varchar2. So varchar and varchar2 are same. There is no difference between these two as of now till Oracle 12c. In future versions the functionality may change. That means the data type, the functionality of data type varchar may change, but varchar2 remains the same with the existing functionality whatever we have till date. Now varchar2, it is variable length character data type. The maximum size of varchar2 or varchar is 4000 byte or 4000 char. Size specification is mandatory. There is no default size because size is mandatory. The characters allowed into varchar data type is uppercase alphabet, lowercase alphabet, all numbers, that is digits 0 to 9 and all printable characters, that is special characters included here. So in general terms varchar2 also allows all printable characters including alphabet, digit and special characters. Now let us see one example. We are creating a table T underscore XX. The C1, we have 3 columns C1, C2 and C3. C1 is number, just for sequential numbers to enter the data into this, and C2 is char of 10, C3 varchar of 10. As we already know, varchar and varchar2 are same, so here we are using varchar, there is no difference. We can also use varchar2 here. Now the size what we have given for char and varchar is 10 each. Now when we describe the table, the structure will be displayed like this. This is char of 10, this is varchar2 of 10. We are inserting 3 rows into this table. First we are inserting A, next AB, next ABC. So we are inserting the same data for both char and varchar data types. Now when we select the data from the table, it will be displayed as A, AB, ABC. So visibility, there is no change when we see the data directly from the table. When we display on SQL Plus or any IDE, we don't see any difference directly because there will be hidden characters. Now select C1 comma C2 and length of C2, C3, length of C3 from the table. So we are displaying C2 and C3 columns, and beside that we are displaying the length of each row. See, C2 is character, it is displayed A, ABC, AB and ABC. The length is displayed 10. In case of varchar, which is C3, C3 is varchar, it is displayed as 1, 2, 3. So here actually we have inserted A, AB, ABC, that is 1, 2, 3 characters respectively. In case of varchar, it is displaying as it is, but in case of char, it is displaying the 10. That means whatever the maximum size we have specified for the column, the same length is displayed irrespective of the number of characters present in the table. See, here we have 1 character, but actually it is showing as 10 characters. That means there are actually 10 characters in this column. Even though it is showing as only 1, but actually there are 10 characters inside this. That means 9 invisible characters are present. Now we are taking the C2 column. We are trimming, R trim. R trim means we are trimming the characters on right hand side. We are trimming the blanks on right hand side. Now it is showing as 1, 2, 3. That means the blank spaces whatever is present on right hand side is trimmed off. So actually in case of char, there is blank padding, means padding is nothing but adding, addition. Blank is a white space. Spaces will be added automatically to the given characters to its maximum length. Since we have specified maximum length as 10 for char data type, when we give less number of characters for this column, it will append or padded, the spaces will be padded or added to the given characters to make the total length of the given characters as well as added characters together as to its maximum length what we have specified while creating the table. Since we have specified the maximum size as 10, here we are giving 1 character, so the balance is 9. 9 spaces will be added here. So where the spaces will be added, whether it is on left hand side or on right hand side. So normally character data is left aligned. Since character data is left aligned, characters will start printing from left hand side. So first it will print the given characters, first it will take the given characters, the remaining characters will be filled with blanks, that is on right hand side of the data. So now On right hand side of this data we have extra spaces, here 9, here 8 and here 7. So when we trim that using R trim, so right hand spaces are removed, so the length is coming as 1, 2, 3. If we do the same thing with L trim, that means if the spaces are on left hand side, remove those characters. If you do with L trim, still the length is 10. That means the spaces are not on left hand side. So this is the proof that the spaces are not added on left hand side. The spaces are always added on right hand side. That is why when we apply the L trim function, the length is still 10, but when we apply the R trim function, the length is 1, 2, 3, which is the actual number of characters. That means it is proved that the spaces are added on right hand side of the given data. Next, what is the proof for only the spaces are added? Now let us use translate function. We are translating the white space, the blank, with $sign. If there is any space, translate that character to $sign. So now when we apply the translate function on character data type column, that is C2, see A is our data and the rest $9 are displayed. Here $8 and here $7 characters are displayed, and this is C3, A, B, ABC, this is C3 column. That means it is also proved that the added character is a blank or a space only, and this space is always added on right hand side only, not on left hand side. So now when we see the differences between char and varchar data type, char is a fixed length character data type, varchar is variable length character data type. In case of char, the maximum size is 2000 byte or 2000 characters, but in varchar it is 4000 byte or 4000 characters. There is a blank padding in character data type. There is no blank padding in varchar data type. Blank padding means adding extra spaces. So blank padding is present on right hand side of data in case of char data type. Next, in both the cases, the characters allowed is the same. There is no difference. Both will allow all printable characters. In char, the size is optional. The default size is 1 byte, but in varchar the size is mandatory. There is no default size. We have to specify the size. These are the differences between char and varchar data types. Now let us move on to the another feature. We know that the size can be specified in byte or character. What does it mean? What do you mean by specifying the size in byte, and what do you mean by specifying the size in char? Up to Oracle 8i, we can specify the size only in bytes. Specifying the size in char is added in the version Oracle 9i. Before 9i, we cannot specify the size in characters. We can specify the size only in byte. See the second example. We are creating a table T underscore char. First one is just number, like serial number. First one is char. Since the size is optional, take one example, creating a table T underscore char. Here the first one is C1, which is number. It's a serial number only. Next C2, the char. We have not specified the size here because the size is optional. Next, char of 1, we did not specify whether it is byte or char. Next, we specified 1 byte and 1 char. There is a difference between byte and specifying the size in byte and char. This I explain later. See, the table is created. So for char, without size, with size, without byte or char, or with byte, with char, all are allowed. Table is successfully created. But when we describe the table without size, with only number, with 1 byte, all are displayed as same. That means all are same. If you don't specify size, or if you specify only number, or if you specify number of bytes, all are exactly same. So in all these cases we can enter one character only. So when we specify 1, the number of character is 1. See here, when you don't specify the default size is 1 byte. When you don't specify the size byte or char, by default it will be 1 byte. So when we specify only number, by default it will take only byte, it will not take char. If you want to specify as char, we have to explicitly specify 1 char or 3 char, 4 char, like this. See another example here, varchar of 10, varchar 2 of 10, varchar of 10 byte, varchar 2 of 10 byte, varchar of 10 char, varchar 2 of 10 char. So when we describe the table, all are displaying as varchar 2. That means there is no difference between varchar and varchar 2. They are exactly same. Now the 10 is coming as 10 byte is also coming as 10, but 10 char is coming as 10 char. So if you specify the size with bytes or with only number without byte, they are exactly same, there is no difference. But when you specify the size as char, there is a difference. Now let us see what is the difference between specifying the size in byte or char. As we already know, specifying the size in char is added in Oracle 9i. Before Oracle 9i, we can specify the size only in byte, not in chars. When we specify the size in char, we can enter multi-byte characters. When you specify the size in bytes or without byte or char, only number, in these two cases we can enter only single byte character data. That means when we say single byte character, it is a character which has 1 byte as storage space. So 1 byte characters or single byte characters are only allowed when we specify the size as byte or when you don't specify anything. When we specify only number or with byte, in both the cases it will accept single byte character data only. Means when we say single byte character data, the character which has the storage size as 1 byte. When we store the character in the database, it will take only 1 byte as storage space. That is single byte character data. And in case of char, in this case we can enter multi-byte character data. That means the character which has more than 1 byte as storage space, those are multi-byte characters. But there is a restriction or there is a limit here. This multi-byte characters, the limit of the multi-byte character is only 4 byte. That means the size of the character cannot be more than 4 bytes. So the maximum size of multi-byte character which is allowed in char or varchar data type is a maximum of 4 byte characters only. That means 1 byte character, 2 byte character, 3 byte character and 4 byte characters are only allowed into this one. If the storage size is more than 4 byte, take an example of 5 byte character, this character is not allowed into this database. So 1 byte, 2 byte, 3 byte, 4 byte, 4.1 byte, 5 byte. So these characters are not allowed into char or varchar data type. 1, 2, 3, 4 up to a maximum of 4 byte characters are allowed into char or varchar data types when you specify the size in terms of characters. So when you specify 10 byte or 10 char, how many characters are allowed? One case we are specifying 10 byte, and in another case we are specifying 10 char. In both the cases the number of characters are only 10. Because we specified the size as 10, the number of characters are 10. There is no difference here. Both the cases number of characters are 10. But in case of byte, it will allow single byte characters of 10. In case of 10 char, multi-byte characters of 10. Those multi-byte characters can have a maximum of 4 byte for each character. And it is not mandatory that all the 10 characters should have the same size. One character can be 1, second one will be 3 byte, fourth one will be 1.5 byte, fifth one will be 1 byte, like this. There is no specific rule that all the characters should have the same size, but the maximum size should not exceed 4 byte. Let us move on to the next data type, which is number data type. This data type allows numeric data, that is the digits 0 to 9. The size is optional. Size is not mandatory here. The size is optional. The default size. So in case of number, the size is called as precision. So the default precision is 38. When we do not specify any size, by default it will take 38 as the default size or precision for number data type. The size can be specified only in terms of precision or in terms of both precision and scale. So what is precision and what is scale? When we say precision, this is the total number of digits in the number, that is the number of digits before the decimal point and the number of digits after the decimal point. That means the number of digits in the integer part of the number plus the number of digits in the decimal part of the number, all together constitute the precision. Together is the precision. And scale is the total number of digits in the decimal part of the number, that is the number of digits which is placed after the decimal point. So we can specify only in terms of precision or in terms of both precision and scale. What are the characters allowed into number data type? Normally everybody knows that number will allow the characters of 0 to 9, that is total 10 characters. Apart from these 10 characters, number data type will also allow few more characters, which is the decimal point, plus and minus. Plus is for positive numbers and minus is for negative numbers. Decimal point is for fractional numbers. So totally 13 different characters are allowed into number data type. Now the precision, the maximum or the range of precision is 1 to 38. So minimum is 1 and maximum is 38. Scale, the range of the scale is minus 84 to plus 126. So minimum is minus 84 and maximum is plus 126. This is the range of scale. So when we specify the precision and scale for a number, it must be within this range. Precision is 1 to 38 and scale is minus 84 to plus 126. Let us take one example. We are creating a table. The first column is number without any precision or size. Second one is having only precision. Third one is having precision and scale 5,2. Now we are creating, since we have a maximum limit for the precision as 1 to 38, so we are creating a number with maximum precision 38, which is allowed. More than 38, this is not allowed. Means this is the proof that the maximum precision of the number data type is 38 only. See here the error message, numeric precision specifier is out of range 1 to 38. That means minimum is 1, maximum is 38. Now we are trying to see the minimum limit. Since minimum is 1, we are giving number of 0, it is also not allowed. It is also out of range. So the precision can be minimum of 1 and maximum of 38 only. Next, let us check the scale. We are giving plus 126, plus 127 allowed, 128 is not allowed. So the maximum precision is 127, not 126. So it is allowing up to 127. 128 is giving error, out of range. Minus 84 to plus 127. So this is giving the meaningful message. Let us check the negative part. Minus 83, minus 84, minus 85 is giving error. 83 is allowed, 84 is allowed, 85 is throwing error. That means this is out of range. Now let us insert the data. So we know that we have created a table without precision, with precision of 5, with precision of 5,2. We are inserting the data. Second column we are giving 5 here, we are giving 6 here. 6 is not allowed, so this will throw error. Third one will be throwing error because the maximum precision we specified is only 5. Here we are giving 0.1. The precision we have given is only 5 here. There is no scale. Still we are giving the scale for the second value. Let us see how the data will be inserted. And here we have given 5,2. We are giving without decimal part. Here we are giving 1, 2 and here 6 digits in the decimal part. When we insert, and apart from that we are inserting 1, 2, 3, 4, 5.1 some values and here we are testing for the maximum precision, because what we came to know here is maximum precision is 38. 39 has given error for us. 39 has given error. Here we are inserting the data 10, 20, 30, 38 and then 39, 40. This is also 40, 41, 42 and then more than that. So more number of digits we are inserting, and then when we check that data, see here 1, 2, 3, 4, 5, 3 is not there here. After 2, 4 is there, 3 is not there, because what we have inserted for 3 is 6-digit number. 6-digit number is not allowed here. That is why it is throwing error. And then since the precision what we have specified is only 2, even though we are giving more than 2 characters, it is truncating up to 2 characters. So it will not throw any error, but it will truncate to that many number of digits if you specify more characters in the scale part. But if you specify more characters in the precision part, then we get the error message. And see here the bigger numbers, 38 is allowed, 39 is also allowed, 40 is also allowed. Even though the maximum precision what is mentioned is 38, still 39 digits are allowed, 40 digits are also allowed into the database. This is also 40, this is 41. 41 is also allowed, 42 is also allowed, but you can see the difference in the last 2 digits. See, when you specify 42, 43 characters, last digit means up to 42, up to 41 it is displaying as it is, 38, 39, 40, yeah, up to 40 it is displaying as it is. Beyond 40, so for 41, last it is rounded or truncated to 0, and 42, last 2 digits are truncated to zeros. That means it is automatically adjusting the number and then it is storing in the database. So even though the precision is 38, it is allowing 39 characters, 40 characters, 41, 42, more than 40, more than 100 also it is allowing, but internally 39 and 40 is storing as it is and displaying as it is, but beyond 41 it is adjusting and it is storing in the database, and the same value it is displaying to us. So even though the book says the maximum precision is 38, but practically it is allowing up to 40 digits without any adjustment. Beyond 40 it is accepting the number, but it is adjusting and storing inside the number, inside the database. So actually we can also enter positive numbers, negative numbers with a decimal point also. That is why number data type accepts totally 13 different characters. So 0 to 9 numbers and 3 special characters. One is dot, one is plus, and the other one is minus.